Alright, so what we're going to be looking at today is looking at some word problems, different functions, different periodic equations, and seeing what other kind of things we can do with them. So you spent some time earlier on the unit learning to graph sinusoidal functions and transformations of it. So before we get into looking at new stuff today, I want to make sure that we're good with graphing. So take some time here and see that you can sketch both of these graphs here to see if we're on the right track. Okay, so take some time, try those, and push play and you see the answers. Okay, so take some time here to check your answers. For the first one, we get a lot of information directly from the equation. So the axis is y equals -6. The amplitude is 2. For a period of 360 degrees, we divide it by our k value. Our k value is a quarter, so if we go 360 divided by a quarter, that's the same thing as 360 degrees times 4, which is 1,440 degrees for a period. You should also, before you make your graph, take the period divided by 4. So that gives you 360 degrees, and that tells us what we go up by for each quarter period when we make our sketch. So when you find our starting value, we're going to be going by 360 degrees for every quarter of the cycle. Now, how do we get that phase shift? Now, this is one of those equations where the k value is not factored out from the argument inside the sign. So we can't get our phase shift until we factor that 1/4 out. So I did so here. 17 divided by a quarter gives me 68 degrees. So I wind up with 1/4 bracket x plus 68 degrees inside the sign. So that gives me a phase shift of left 68 degrees. When I go to make my sketch, I'm using the method where I just split one cycle up into quarters instead of using a mapping rule. So if my value is along the y, my axis at -6 goes in the middle. With my amplitude of 2, that means I go up 2 to get my max of -4 and down 2 to get my minimum of -8. My phase shift of left 68 degrees means I start my cycle at -68 degrees. It ends 1,440 degrees later, so add 1,440 to -68, I get 1,372. So that's where my cycle is going to end. And like I mentioned before, take the period divided by 4, get 360. We go up by 360 to get our additional values along the x-axis here. Okay, so in order to get my sketch now, the last thing I need to figure out is what shape my graph will be. So I have a sine graph. So sine graph starts on its axis. This is a reflected sine graph because the negative out in front. So I'm going to start on my axis and go downwards from there. Let's go from axis to minimum to axis to maximum to axis. Okay, so I get my sketch there. Okay, I went through a similar process for part B. Axis is y equals 2, amplitude 5. My period's 24 degrees when I divide 360 by 15. Which means when I divide the period 24 degrees by 4, I'm going to go up by 6 degrees each time. Again, for my phase shift, I had to factor out the k value in this case. Factor out the 15, I got x minus 7 degrees left over, so my phase shift is right 7. So you can see the values I got for my x and y axis. So again, axis was at 2, add 5 to get my max, subtract 5 to get my min. My period starts at 7 degrees, ends 24 degrees later at 31, and again I go up by 6 degrees every single time I go up. So last but not least, to get my shape, this is a positive cosine graph. So cosine starts at its maximum, it's not reflected, so I start by my max, go down, and then back up to finish my cycle. Okay, so we're going to need that going forward. We're going to need to be able to make sketches of situations. And one thing we need to remember here is we found our period always by taking 360 degrees and dividing by k. We can also rearrange that equation to get k by itself, which means if we had our period and we're trying to find the equation, we could do 360 divided by our period to get the k value in the equation. Okay, so with all that in mind, I want you to state the domain of 4 complete cycles of the function y equals -5 cos bracket 9x was 108 degrees minus 14. So what I suggest you do first here is create a sketch, and then from there we can get an idea of what it looks like and then try and find the domain of 4 complete cycles. So try and make a sketch on your own first, and then we'll answer the rest of the question from there. Okay, so to make your sketch, quickly take a look at where all this information came from. Hopefully your sketch looks something like this. If it doesn't, please come see me. We'll run through it together. Now, what this asked for was the domain of 4 complete cycles of the function. So now this is a little bit arbitrary because which 4 cycles does it mean? Are you taking this cycle and taking the 3 cycles after this? Are you taking the 3 cycles before this as well? Are you taking 4 other cycles? It's kind of arbitrary in this situation. So to make our life easier, what we're going to do is we're going to take the cycle that we have here and then just take the 3 cycles on the end after this to get our 4 complete cycles. So starting from here, we're starting at -12 degrees. Okay, so I'm going to choose to start at negative 12 degrees. And one cycle, you'll notice here, remember, took 40 degrees. Okay, so 4 cycles is going to take 4 times that, which is 160 degrees. Okay, so 4 cycles will take 160 degrees to complete. If I go negative 12 plus 160, that's going to give me 148 degrees. So that will be my domain. Any possible x value between negative 12 and 148 degrees. And again, remember, this was arbitrary. If I wanted to, I could have chosen this cycle and 3 to the left. I could have chosen 2 on the left, 1 on the right. I could have chosen 4 cycles further off, start way the heck down in the thousands of degrees. So really, because the domain normally is x an element of the real numbers, chopping off 4 complete cycles, it's really kind of arbitrary as to where you're going to do that. But in theory, if you were going to do it, this would be one possible answer. Okay, so now we spent a lot of time making graphs. We haven't spent a lot of time making equations. So we're trying to go backwards now from the graph to try and create the equation. So what we're going to start with here, and now it is possible to make both a sine and a cosine graph for each curve that we look at, and it depends on what we want to use as a starting point. So what I want to start with here is first trying to find out all the key features. So remember, to create the equation, we're going to need to know the amplitude. Okay, we're going to need to know the axis, and we're going to need to know the period. Okay, that needs to be known first and foremost before we can even think about making an equation. Okay, so take a second here and look at the graph and try and figure out at least those 3 parameters: the amplitude, the axis, and the period, and see what we can come up with. Okay, so you should get something like this for those 3 values. Now, I started with my axis. Now, depending on the graph, this is one of them. You could eyeball it and find the value that's halfway between your max and your min. It's going to be at y equals negative 2. And you can potentially visually see it here if I draw it in. Okay, now, it's not necessarily, if you can't necessarily look at it from a graph, remember that you can always calculate it from the max and the min. It's going to be halfway between the max and the min, so max plus min divided by 2. So my maximum value is 3, my minimum value is negative 7. Add together, divide by 2, you get y equals negative 2. Okay, for my amplitude, again, might be able to eyeball it from looking at the graph. If you can't, though, remember you can calculate by going max minus min divided by 2. 3 minus negative 7 is 10, divided by 2 gives me 5. For my period, I just decided to isolate one cycle, and I chose to go from the minimum to minimum here. That's a good way to get a cycle. I could have gone maximum to maximum, but you can't really see another maximum on this particular graph, so that wouldn't work. I could have also, if I wanted to, gone from, let's say, here on the axis over to here and gotten a cycle that way. Either one will work. You'll get the same answer regardless. But this one, the cycle I isolated down here, it starts at negative 600, ends at 120. That's a distance of 720 degrees, so that's my period. Okay, so how does this help me? Well, remember that the amplitude gives you my vertical stretch. The axis gives me my vertical shift. The period, I can use it to find my horizontal stretch or compression. So remember that k is going to be equal to 360 degrees divided by my period. So when I throw that in, I'm going to get a period of 360 over 720, which is a half. Okay, so I already have a lot of the equation right here. So let's say I want to create, now it says here to state a sine or a cosine graph. So I'm going to start by creating a sine graph. So it's going to be some amplitude. It's going to be, so my amplitude is going to be 5. I'm going to put that in here. Okay, so my k value is a half. I don't know my phase shift yet, so I'm going to leave that part out. I know my axis, which is minus 2, so I'm going to throw that in at the end. So there are 2 things missing here. I don't know if I have my sine graph being reflected or not, and I also don't know my phase shift. So what that's going to depend is where I want to start my graph. Now the nice thing is I get to choose where I want to start the cycle. However, if it's going to be a sine graph, remember, looking at your parent functions of sine x, the sine graph, the cycle starts on its axis. So we need to find a spot where this graph is on its axis to find the starting point for the cycle. So it might help again if I draw this axis back in. It was at y equals negative 2. Okay, so where is it on its axis? Well, you can see a spot right over here where it's on its axis. Now there's also another spot here, we'll deal with that. But this is a spot where it's on its axis. So if I choose right here, this has an x value of halfway between negative 360 and negative 480, so that's negative 420. So if I start here, my phase shift, if it's starting there, is going to be left 420 degrees. Okay, if it's left 420 degrees, I'm going to have x plus 420 degrees inside the equation. Okay, so from there, if I start here, is my cycle reflected or not, or is it the same as the parent function? Well, it's on its axis. From here it goes up, so that's the same as the parent function. It's not reflected. This is a perfectly valid equation. Okay, now what if I had chosen not to start the cycle here, but start the cycle elsewhere where it's on its axis, like let's say over here? Okay, again, I could do that, but it's just going to create a couple of slight little differences. So if I choose a different place to start my equation, so I'm still going to have 5, still have sine, my k value is still a half. Okay, my phase shift might be different, my axis is still the same. So if I start here, now I'm starting at negative 60 degrees along the x, so my phase shift is going to be left 60, so I have x plus 60 degrees. Okay, and this one, if you'll notice here, if my cycle were to start here, it's now going down from the axis, which is the opposite of the parent function. This one's actually been reflected. So if I start here, I have to make sure I put a reflection out there in front of the equation. Okay, and I could go on forever. I could create another one right here. This one would have a phase shift of right 300. So I could also have y equals 5 sine of a half, and what did I say, 300? Yeah, 300, x minus 300 degrees minus 2. And again, if I were to start here, the cycle goes up from the axis, which is the same as the parent function, so it's not reflected. So it only asked me to create one sine equation, but I've actually created 3 possible answers here. These 3 are all completely equivalent. If you put them into Desmos, graphing calculator, whatever, they will create the exact same graph, and it will look exactly like this one right here. Okay, so all that was to create sine equations. We can do the exact same thing for cosine. Okay, so let's clear all this out here. Now, if you're creating a cosine graph, you'll notice that most things are actually going to be the same. Our axis isn't going to change. Our amplitude doesn't change. It's the exact same graph, right? All that's going to change is where we decide to start. So let's just say we want to create a cosine graph. Okay, my amplitude's still 5. Now it's cosine. My horizontal stretch compression factor, my k, sorry, is still a half. I'll worry about the phase shift. And my axis is still, oops, so I still have a half. Okay, so again, I find my phase shift and whether or not it's reflected. And again, I get to choose a starting point. Let's say if I want to choose a cosine graph, remember that cosine graphs will either start at the maximum if it's the same as the parent function, or they'll start at the minimum if there's been a reflection. So let's start with one where that hasn't been reflected. Let's start at the maximum here. So you can see right here the graph is at its maximum. So if I start there, this is now a shift left 240 degrees. So I get x plus 240 degrees in the equation. Okay? Because this is at its maximum, it has not been reflected, so it stays positive out here. So this is a perfectly valid cosine equation. So at this point I've answered the question, but let's again, for extra practice, see if we can get some other cosine equations as well. Let's say I want to start down here at a minimum instead. So if I do, now I'm starting at negative 600 degrees. So I still have 5 cos of a half. It's going to be x plus 600 minus 2. Because I start my minimum though, this has been reflected. So I need to put that negative out in front to indicate the reflection. If I want to do the exact same thing for this particular point over here, this would be starting at 120 degrees, so that would be a shift right 120 degrees. It starts at its minimum, so it's been reflected as well. So I have negative 5 cos, a half x minus 120 degrees minus 2. Okay, so that's an example of how you can find multiple sine and cosine equations. I'd like you to try this one on your own. I'll run through it in part 2.